Hello class, this is the mock exam review 2016-20 and we're working on problem number 21 from the mock exam. Alright, let's get started. Let's calculate Z total first. Z total, by definition, is equal to the square root of R squared plus XL minus XC squared. And then you have the angle, which means that we must take the value of the X total and divide it by the R total, and we must do the inverse of that to get the angle for Z. Alright, so first let's calculate XL. Okay. XL comes from the formula 2 pi FL. So after we calculate that value, I'll give you the number. This is the value of XL that I calculated. You can check on your calculator to see if you get the same result. Now, the next value that we need is XC. This is the value of XC that I calculated on my calculator. That comes from the formula 1 over 2 pi FC. You can pause the video and calculate the value to see if you get the same results. Okay, I have the value of XL and XC. According to the formula, I have to take XL minus XC and then put it into the square root formula. XL minus XC is equal to negative 375. The reason why we get a negative is simply because the value of XC is bigger than XL, which means that it follows along the negative J-axis on the complex plane. Or you can say that it has a magnitude of 375 ohms, but it's on the negative 90-degree axis. So now we can put those values into ZT and get our ZT total. I was able to get 435 ohms for my ZT total. Okay? But this is not enough. We must also calculate what is the resulting angle that will be between the Z total. So to do that, we must use the second formula. So we will use the tan inverse formula to calculate the phase angle. So let's calculate the phase angle of Z total, and then you can check the results on your calculator. I received an angle of minus 59.6 degrees, or almost, you could say, minus 60 degrees. Alright, so that will conclude the first part of this video series where we calculated the impedance and phase angle. Impedance is another word for Z total, and the phase angle that goes with that impedance will be the angle that you calculate between the reactive component and the real component. Thank you. The next video will calculate the total current